Happy Monday. How's it going, everybody?
It's going well. Good to see you, Joe. Welcome, Lucas. It's really great to see you here.
Good to be here. I'm happy to talk about some data stuff this morning.
Data stuff. All right. And then some housekeeping stuff before we get started. If you're joining us from LinkedIn Live, the original link, somehow the showtime changed on it. Wasn't me. I think some of the friends have been having issues with StreamYard too. So anyway, if you're joining, make sure to join the link I just posted, and that'll be the right one. Anyway, Lucas, for people who don't know who you are, do you want to give a quick intro?
Yeah, super quick. I'm Lucas. I'm the CEO of a company called SDF Labs. We're working on a semantic data product where the idea is that you have slightly better understanding of a warehouse from ingestion to consumption. And there's some very nice benefits that we can start building on top of that. My background is originally in sensor analytics. So I was super interested in sort of helping computers understand the real world better. Yeah, at some point that sort of led into the ML universe and computer vision. My last company I was leading engineering for, I was building computer vision products for mobile devices, and we ended up building up several different data stacks. And the company grew, and then we ended up building up some more data stacks. And all of a sudden, we started getting into some real challenges in terms of just understanding, what actually was happening where, right? Where is our user data going? How can we delete users appropriately when they would like to be deleted? How do we deal with data retention? And that sort of led to what SDF is now.
What does SDF stand for?
It's the Semantic Data Fabric.
That's a lot of buzzwords.
It's a lot of buzzwords,
but it's great. Yeah. I mean, I think it touches a few nerves for sure.
Yeah, yeah. So I guess I mean, I thought a little bit about where we could sort of kick off the conversation, but maybe the first thing to talk about is understanding like what are semantics and why do they matter, or at least why do we think that they matter? And the simplest case to maybe start off here is with maybe it's not the simplest case, but what is a daily active user? If you sort of go to different organizations, people will tell you different things, right? Even daily active user, daily might have multiple definitions. Active could mean several things, and even user might have multiple definitions, right? Depending on if a user is based on cookies or the mobile site or mobile and web for some organizations. So even something as simple as daily active user, right, which is such a core metric for a lot of organizations, might have very different semantic meanings depending on what business unit you're in, what company you're working in. That makes it very, very difficult to sort of scale an organization because that meaning is so fluid. Yeah, but I don't know. Have you? I'm actually kind of curious.
We've never seen this before in our entire lives.
Never in our lives.
I'm kidding. This is brand new to us. Right. Why would this ever happen, Lucas?
Why would this happen?
Why are we so confused?
Why? Yeah, precisely. So I'm kind of curious, like Joe and Matt, like how do you see companies currently sort of tackling this problem?
I mean, often they aren't, right? You have, frankly, somewhat poor human processes to try to address these issues. So you have analysts who kind of know all the hidden cobwebs of the company. You have their own bespoke SQL queries that they run that are meant to return key metrics. And then if you get a different answer, then you have to go talk to the analyst down the row and say, hey, how are you getting your answer? Like, why are our answers different? And then you sort of comb through the SQL to look for where the differences are. And then you compare that to the supposed official business definitions, and then you try to come to some consensus. If you're lucky. If you're not lucky, then you have different parts of the organization sort of backstabbing each other with their own numbers.
I mean, and some of this is by design, I would say, too.
Yeah, there's truth to that.
You don't want to... sometimes common definitions aren't doesn't serve the business. But I think how you discover this is interesting, because often it's, from what we've seen, it's management or executives looking at numbers, and they're often saying, why doesn't this look like this?
Yeah,
what's wrong here? Then of course it's like, oh, it's the idiot data guy over there who probably doesn't understand what's going on, or any number of things, right? And I think to Matt's point, I think what we've often seen happen is, I remember there's one company I worked at, and we were trying to figure out what is a customer. This is a very, very classic problem, right? And
Yep.
so what we thought would be a very easy exercise ended up being 3 weeks, and then we ultimately decided that there wasn't a true definition. We'll just use all of the above, and we'll just name them differently,
Right.
and that's sort of the band-aid that you put on it. But that's what happens, right? You start. It's not like you start a company, when it's small, and say, "Oh, definitely, our intention is to have deviating definitions of everything and confuse the living hell out of people." I don't think that anyone sets out to do this, but
Right.
the Joker wasn't born thinking he'd live a life of crime when he was older either. So that happens.
Sometimes things just happen.
They happen.
Yeah. I mean, I think one of my favorite stories here was I have a friend who's a head of data in New York. In New York, actually, and at some point he was in got called in by the CEO and the CFO because their quarterly numbers weren't adding up. They spent 3 or 4 days really going into the deep end of trying to figure out why the numbers didn't add up, and someone had just sort of aggregated Canadian dollars and US dollars on the marketing side, and on the finance side they had done the conversion from Canadian dollars to US dollars appropriately. But this is sort of the thing, right? SQL engines themselves don't really have a higher level understanding of what data types are, right? It's all varchars and decimals, right? So you can always aggregate 2 decimals, even though logically you might not be able, or you should not be able to aggregate 2 decimals, right? One might be Canadian dollar, the other might be a US dollar. They're both decimals, but you definitely should not be aggregating them in probably most cases.
Well, and in practice, what does this data structure look like? What does the data model look like? Well, you probably have a price or a revenue field, and then you have some other text field that tells you your currency. And then you might even run into situations where the currency is not marked consistently, where you have different names for the same currency, for example. This is the kind of nonsense that you have to think about.
Yeah, and it is a lot of nonsense. But so I think, I mean, there's some interesting, we talk a lot about SQL here and sort of where it came from. But SQL is a very old language at this point, right? So even things that you expect in software engineering a lot of the time, higher level types are not available. There's another sort of really interesting problem with in sort of the semantic space, which is friends. So
like us,
like all of us, exactly. Happy Monday. But for typically in software engineering, you have this concept of friend relationships, right? Where elements can use something from a friend. In SQL, you don't have this at all, right? Everything in the database is essentially completely open, which means that if you want to migrate from one definition to another definition, that becomes really hard because everything is always a friend of everything else, right? So there's a lack of structure a lot of the time. And that means that creating different semantic meanings and having them propagate through ends up getting really, really, really difficult.
It happens.
Cool. So, yeah. So I guess maybe we can sort of talk a little bit about where this is going.
Let me ask you this question: what do you think about the more classical methods such as master data management? What's your opinion on that? Is that something that has worked well, or has it failed businesses?
It's a very, very interesting. I think it works well up to maybe a certain point, right? There's always this question of scale. So you look at JavaScript and TypeScript. If you're building a smaller project, JavaScript is a perfectly good language, but at some level of scale, having everything be an object that is visible essentially globally on the DOM starts getting to be a problem, and all of a sudden you want something like TypeScript that gives you higher level abstractions and a little bit more rigidity around your development environment. And I feel a little bit similarly with something like MDM, where up to a certain scale, maybe a dozen data engineers or something, it seems to work okay. And then at some point things start breaking down. People join, people leave. You have multiple definitions in multiple places. I don't know. I'm curious to hear your opinion on this as well.
That's a good question. I guess I have mixed feelings. I think some MDM practices have worked well. but there's also a reputation in some organizations that MDM is sort of this master control that doesn't really help the business move forward. So I don't know. What are your thoughts on this, Joe?
I have a lot of friends in the MDM space, so it'll be nice. I agree with what you guys said.
Right. Perfect. Yeah. Yeah. It's the same goes for I think a lot of companies working with data, right? Scale really changes like what your business processes can look like. If you're a single data engineer, you're the master of your own domain, right? You can structure everything how you want to. If a customer customers with over hundreds of thousands or over 1 million tables, managing that is a completely different ball game, right? And what we, I think, are trying to figure out is how do you add a little bit more structure and a little bit more semantic understanding on top of these really, really large systems.
Mm-hmm. Yeah, it's an interesting one. I was talking to Dave McComb the other day. He runs a Semantic Arts. I think he may have been one of the first people involved in applying semantics to the enterprise. And his whole thing is, you have a company with, thousands of applications, right? A lot of third-party applications too, which is, you're not going to be able to get into the inner workings of these things and the tables and so forth. They may provide you with the schema, maybe in or out of date, who knows? But he's really keen on applying knowledge graphs to solving this problem and really taking what is maybe thousands of concepts and distilling them down to maybe a few hundred in a very extreme case, right? So that's definitely one approach that he's taken. But I'd be very curious, how you're viewing the world through through SDF and so forth.
Yeah.
So I think when you showed me, when we met like a few months ago, you showed me, some of the static analysis you're doing on SQL, and I was like, holy crap, that's actually super useful, and should be widely used, right? Like, I thought that was
very cool. A little bit the goal, right? So maybe 2 words about the knowledge graph component. So I think knowledge graphs are really interesting, right? Because they've been around for a while. But it seems like they're only now really starting to make it into the mainstream, because there's this quest for, rather than just dealing with individual queries, can we build business logic around them, right? And this is for a few reasons. One is, this data growth is exponential, hurrah, hurrah. But also there's increasing pressure from even just like a compliance side, right, to understand where certain data is going. And understanding that a varchar is going to various places isn't helpful there, right? Like we've seen, in a lot of the warehouses that we work with, something like 50% of the data types are varchars.
Oh, great.
So how do you make sense of this, right? And I think this is where the knowledge graph sort of component comes in. It's another company called Relational AI that is working on some similar stuff. And we've heard, I think, across the industry that there's sort of this quest to level up from, hey, dealing with varchars and ints and decimals to dealing with higher level types, because once you have higher level types, then you can deal with business logic on top of them, right? It's very hard to deal with business logic on top of varchars.
Mm-hmm. And I'm looking at the chat here. I mean, you got Ole, you got Jessica, you got some other people who have been keen on the whole semantic and knowledge graph space for years, and they've been guesting the show, and definitely seems to be resonating. I mean, who is it? One Cicada is another person who's really been talking about graphs and I think pushing that forward with respect to LLMs. But I mean, he is part of the semantic web from day one as well, right? So it's like it just feels like one of those things where it's like everything, it's often easy to be early into stuff, which doesn't mean it's wrong. It just means that the party hasn't started yet. But it really feels like that's definitely changing. So
I'm just reading through a couple of comments here. If Microsoft is starting to use the semantic model again, that's how you know that it's really hit the mainstream, I think.
Jake Carter's another one here. Almost got winning. And Donald Parrish's comment. Microsoft started using the term semantic model, Power BI again. I think Jessica said maybe I'm not sure if she's referring to 2012 as being when they started using it. But anyway, it is what it is. It's being used. So and what's up, Sonny Rivera? Good to see you here. So, yeah, let's get into demo mode though. I think you got something you want to fire up here, and let's see what you got here. Do I need to bring you
Yeah,
on? Can you
There it
zoom in
is.
on that by any chance? I'm sure the
absolutely.
audience will be having a new eye prescription after this is done.
All
Let's
right.
go on.
Is this large enough now, I assume?
Maybe a bit more.
All right. You should see how big it is on my side here. It's absolutely massive. Cool. So maybe I'll share 2 words about what SDF actually is, and then dive into demo mode. So SDF, the idea behind SDF was really to help build up the semantic model, but but specifically for existing data warehouses, right? Most companies at this point have built out these this very large trove of existing SQL queries, but typically SQL engine, as I mentioned before, is still pretty primitive, right? It will take a single query and some data and give you back some more data. And by always working within a single query, you sort of lose the end-to-end understanding from ingestion of data to the consumption by various business units. And SDF is essentially a static analysis engine that can take in many, many SQL queries at once, arrange them appropriately in a DAG, create things like lineage, but then also propagate classifiers. And what ends up happening is that those classifiers start working like types. And all of a sudden you have this very powerful semantic model that sort of spans end to end by construction. And because it's static analysis, the whole thing works on code directly, works on SQL queries, and doesn't need access to data. And that means it's also quite fast and performant, meaning it's easy to integrate. So I think we've come a huge way with monolithic SQL engines that focus on optimizing the heck out of a single query. And what we've sort of designed SDF to do is work with many, many queries at once and provide that end-to-end understanding. So what you're looking at here is an SDF workspace. It's a little YAML configuration, and this workspace is structured around the TPCH queries, which Matt and Joe, I'm sure you guys know those, the TPCH queries, right? It's the classic analytic.
Yeah, I remember. Yeah. Are you want to take questions now, or do you want to wait until you're done?
I'm happy to take questions now.
Yeah. So Mark Keeling was more a comment. It seems what you described there might be some overlap with DBT. How would you address that comment?
Yeah. So there's some. So structurally, there's some overlap with DBT. I think even in some of the YAML configuration. So DBT generates. When you run DBT compiler, right, DBT generates all the SQL queries for you. SDF takes in existing SQL queries. So some aspects are similar, but because SDF is actually compiling SQL queries and doing type bindings, you can get errors in a much closer to development time. So if you think about like hitting DBT run, first your Ginger is expanded into a SQL query. Then that SQL query is sent to an engine like Snowflake, and then you get back the Snowflake response, right? So even if it's something as simple as a syntax error, only Snowflake, only at sort of the Snowflake layer will you get a response back. SDF does that compiling in place on the existing code base.
That's a good one. And then Jessica's asking, can you represent more than types?
Like what?
Jessica, clarify your question.
Yeah.
Please. Thank you. Okay.
Yeah. So the idea here was types can be basically anything, right? So types can be things like currencies, right, which is what we'll see in the demo, but they can also be things like retention, right, based on PII. Right, so you can say that something is PII and that PII should have a retention of 3 years, and the idea is that this then propagates throughout the entire warehouse. So the idea is that types, metrics, retention policies, that all of those things can be represented with SDF.
So in the clarification, Jessica says relationships, properties, classes, and attributes.
This is a great question. I'm going to be totally honest. We haven't explored the full potential of what we can do here. So initially, the system was the initial sort of genesis of the system was to model a little bit of a meta project called UPM, their universal programming model for data. It's just something that my two co-founders were the architects of, and so the initial goal there was heavily around, can we deal with privacy and governance and GDPR? And what we found is actually that the business model, the metrics and various attributes elements end up being much more interesting to companies, because all of a sudden we can create a canonical definition of a daily active user for a specific business unit. And in the demo here, we'll show a way to prevent leaking personally identifiable information into a public schema ever. So those are no longer things just around governance or data privacy, but they actually help with exactly what we've been talking about here, which is creating a semantic model for a data warehouse end to end. It's maybe a roundabout answer.
Well, I really like that idea, because speaking of shifting left, we really need to think about shifting privacy left. Like, it needs to start at data generation. And that's why we had so many problems when GDPR came out, because none of this stuff was engineered to respect privacy.
Yeah. And this is going to continue, right? There will be inevitably regulation around LLMs, and what we've already heard from companies is, hey, can we get a way to get a bill of materials for a specific training data set? Because that's something that's incredibly hard to do currently, right? How do you know what data and whether certain user consent was agreed upon when you're pulling a data set to train an ML model? And frequently, because these models are so iterative, you need hundreds of different data sets. And establishing sort of semantic meaning for what is actually the inputs for those data sets is incredibly difficult.
So it's interesting. I gave a talk on the future of data engineering at Crunch Conference on Friday, and I was talking about this very issue where LLM training is where big data was in the early 2000s, which is just grab anything you can and don't worry about where it comes from. Don't filter it. And it's completely insane. It's understandable in the early days, but this situation cannot persist. There's
and it won't. I mean, at least in the EU, because I mean, the EU AI Act that's about to be voted on, even as soon as end of November. And shameless plug, we have Kai Zenner, one of the architects of the act, on the show next month.
Cool.
That'll be pretty interesting. But that has huge ramifications. I think after it's signed, you got 6 months to comply or something like that, or I don't know, some short period. Maybe it's 2 years. Maybe I'm just making stuff up. But either way, you don't have a lot of time, right? Especially in a field like this where everything's changing so fast with LLMs. And like Matt said, you're just gobstopped trying to get as much data as humanly possible. Although the interesting thing is, for public data sets, there's actually a paper that came out. It's a complete tangent, but welcome to talking to Joe. The paper was, there's actually might be a shortage of data really soon for large language model training. Or you hear an asymptote. So, but that's a lot of data you're talking about still, right?
Yeah.
Like I'm not going to hair split it. It's just it's mostly the internet. So I don't know.
Right. Yeah, but I think what we've seen is that companies internally want to build like specific business solutions tailored to their needs, right? So there's like, I think this rise in sort of general purpose models, and then, hey, whatever, we're in the insurance industry and we're trying to figure out how to optimize some specific process that's super niche to the insurance industry. Can we take the existing internal company data that we've been building over the last decade and operationalize it? And that I think is sort of the big question for a lot of these larger enterprises at this point.
Yeah.
Cool. So, jumping back from the tangents, what are we looking at here? SDF, again, goal is end-to-end understanding of the data warehouse. So we have here TPCH. This workspace is scaffolded around TPCH. We're including 3 directories: sources, queries, and external. Sources is all of the TPCH sources. These sources are just external table expressions where we're pulling from a Parquet location that is also local here. It's this SDF datasets directory. It just contains some Parquet files, but that's sort of where we get our schemas from. We have queries, the 22 famous TPCH queries. We have an external schema here. Notice here, path external has a different default schema. This has some public customer info. It's where maybe represents a schema that we are releasing to the public, and we probably don't want to leak any PII there. And then we have code checks, which we'll dive into in a little bit, but those are sort of unique to SDF and can run at sort of compile time. So what is SDF? SDF is a SQL compiler written in Rust. Wow, let's make this a little bit easier to read. What the first thing we're going to do is run SDF describe. So what SDF describe does is static analysis of the entire workspace. So what we're reading in all of these SQL queries, all the data sources, we're pulling the schemas, we're doing tight bindings, and you'll see that these queries are not in order because SDF internally creates the DAG of dependencies from this query set. And again, because it's static analysis, we'll see that it took whatever 0.14 seconds because we don't actually have to access any data, right? All of this is just running directly from the SQL code. So this is cool, right? Great. Now we have some columns, we have some data types, we have whether they're nullable or not. And now we have this beautiful empty classifier column. And I think the classifier column is where hopefully the magic sort of starts to happen a little bit. What we're going to do is create some classifiers. And we're going to attach those classifiers at ingestion. And again, the idea is that SDF will carry those classifiers from ingestion down through consumption, thereby giving you your data types. So we've created two classifiers here, one called currency, US dollars and Canadian dollars, and another called PII. We're going to have name and phone and address. And what we're going to do is attach those classifiers to just a couple of columns in the input tables. So we're going to take like the line item table, which contains all the customer purchase details. We're going to take the price and the discount and the tax and say that all of that is currency.usd. We're also going to take the customer table, and we're going to say that, hey, in the customer table, which contains all of our customer details, we're going to say that the name is pi.name, address is pi.address, and phone is pi.phone, right? So what we've done really is just we've said we're going to create two types, currency and PII, and we're going to attach them to just two tables and various columns in those tables. Relatively straightforward, right? I think there's probably other ways that you can do this. Shout out Iceberg. There's a dictionary where you can attach classifiers, but this is sort of the YAML SDF representation. Cool. Any questions so far, Matt or Joe?
Well, Jessica had a question here. Are types primitive?
Types are primitive and can be user defined or SDF. We have a schema that companies can use. If you run SDF describe again, we see something kind of magical happen because now across the entire warehouse, we now see that in Q15, total revenue we know is currency.usd. We know that the sum of the profit in Q9 is also currency.usd, right? You see that throughout this entire warehouse, we now have this very detailed understanding of where currency is, where PII is. And crucially, we can see here that in our public customer info table, our CNAME here is some PII. So this is pretty magical, right? All of a sudden we know, hey, it's not just revenue, we know the currency, and these classifiers are additive. You can add more than one classifier to a particular column. And if you ever want to figure out, hey, how did we get here, right? How did CNAME get this PII.name classifier? you can ask SDF to provide you the lineage. So you can say, hey, SDF, give me the lineage of external public customer info, and specifically the column C_name. So this command is saying, hey, SDF, based on this workspace, based on the classifiers, based on the static analysis, give me the lineage for this particular column in this particular table. And SDF will do that for you. All right, it'll show you that CNAME here came as a copy of Q10, and that came as a copy of customer.cname. So again, all of a sudden, you have this crystal clear understanding of what is happening in a warehouse from ingestion to consumption. And what we found is that especially at scale, this understanding has been missing, right? It solves so many things from, some of the privacy and governance issues that we've talked about, from, canonicalizing various metrics, from dealing with data retention. And we found that it's been able to provide a lot of value because it's a different view of a data warehouse than I think what currently exists. Cool. Been talking for a long time. Any questions?
Yeah, so let's walk through this. The example you gave earlier of currency conversion, where marketing was not doing it and analytics like finance was doing the currency conversion.
Yep.
How would SDF help in that situation specifically?
It's almost like you knew the demo. Let's start slowly. So SDF supports these things called code checks. And what are code checks, and why are they cool? It's kind of niche, and I'm going to nerd out for a little bit. So what SDF is doing internally, you'll see that there's this SDF cache directory, and internally, SDF is creating an information schema, its own little database that has all of the user attached and SDF inferred metadata. Right, so it's this super rich information schema that contains all the lineage, all the types, all the type bindings, all the classifiers, the table level classifiers, dependencies. All of that stuff is contained in this information schema. And then what a code check is just a small SQL query that checks for a certain assertion within that information schema. In this case, we have one code check here, which ensures that no column contains both Canadian and US dollars. It's a not exists assert, right? So what we're saying is this SQL query, this code check, no currency mismatch, should return no rows. If it does return rows, we have a currency mismatch. So we can look at that SQL statement super quickly. It's stupid simple, right? Like, it's 9 lines where all we're saying is, hey, find a column where the classifiers have both, currency.cad and currency.usd, for example. You can create an arbitrarily complex SQL queries. And what happens when you run SDF, describe or SDF test, we'll run SDF describe again. SDF describe then takes the code check, runs that SQL query against the internal information schema, and tries to find, in this case, a column where you have a currency mismatch. So any questions there? That makes sense.
Seems pretty straightforward. Matt, you have questions?
I think it makes sense. Yeah.
We love it when things make sense. So let's break one of these things. So let's take the price. Probably this will break. I'm not 100% sure. Let's say you accidentally say calculate the price is still in Canadian dollars. Run SDF describe again, and oh wow, yeah, so many failures, right? We now see that, hey, here's the failure. No currency mismatch failed, and now we know exactly the table and the column and the sort of duplicitous classifiers here, and why that is causing an error. So crucially, again, these aren't SQL query problems in and of themselves. They're business logic errors, right? So what we really want to do is level up from, hey, can we just execute a particular SQL query, or does this column contain null values or follow a particular regex expression? What we want to level up to is, can we make sure that business logic is consistent end to end throughout a warehouse, regardless of how large your organization is. Great. So I will move this back to USD. There's one. We'll actually add one more code check. What we've done so far is code checks around currency. But let's say we want to deal with a friend or not friend relationship. So what we said earlier. Actually, let me. I will comment this back out. We'll run SDF describe again. Great, all the code checks pass, right? So let's say that this data warehouse has an external schema, and that schema should never contain PII information. And unfortunately, we know here that public customer info, the column CNAME, is some PII. If you create this code check, again, this code check, all it's checking is, hey, is there a table in the schema external with classifiers like PII, right? We're saying that the external schema is not a friend of PII, and we want to prohibit PII from ever even reaching that schema, right? We don't even want to execute any SQL statement that will ever put PII there into that schema. So again, you run SDF describe, and voila, we get this nice failure. Again, we see exactly our table, public customer info, the column, the CNAME has some PII. And how do we fix this now? So there's some additional elements here to SDF that I think work well for large businesses. We can say that something like a SHA-256 function for our organization does a good job of anonymizing PII. So what we're going to do is we're going to take the function SHA-256. It's a built-in SQL function. It takes in a string, it returns a byte array, and now that function also reclassifies, right? It takes, if it's given as input a PII.name, you get back an empty classifier. So we're going to remove the classifier essentially. And what's so powerful about this is all of a sudden you have the ability to have transformations operate on those data types in different ways, right? SHA-256 might operate this way on PII, but it might not change, the state of some other hashed element already. So now that we know that SHA-256 does a good job of anonymizing, we can go into our external query, and rather than grabbing CNAME, let's grab the SHA-256 of CNAME and run SDF again. And what will happen is all the code checks pass. CNAME now is a byte array because that's what SHA-256 returns, and the classifier here is empty. So you have this very elegant, dynamic way of dealing with different transformations across your different data types. I'll end the demo here, but I guess Joe or Matt, any questions about this piece?
Yeah, I mean, how useful is this for? I mean, you said there's a you gave the example of maybe an external schema. I'm guessing you could probably apply this to introspecting upstream data sources as well, like maybe a source relational database from which you're ETLing data. So that'd be maybe the first question. Then I have a follow-on question after that.
Yeah. So there's so yes. So the design here was so that you could import both like a source relational database and a data warehouse and actually connect the two, right? So we can attach a classifier here to on something that's in a Postgres database and have that classifier actually follow through to your Spark cluster, right? So all of a sudden, again, you have the idea here is to work and help define end-to-end relationships rather than dealing with monolithic systems.
Mm-hmm. Yeah, and the second one is I imagine this might be useful for developing ETL processes, for example, right? Where I might have access to the database. I don't know, but I wouldn't. I've just seen a lot of ETL processes that are a bit messy, right? Where it takes in data, munges it, it's not quite sure what the hell it's doing. So I think there's quite a bit you could do with this. So
So ETL processes are fascinating, right? Because there's so many different sources of data that a company typically has, right? Fivetran, like Postgres, we're getting some log files, we're cleaning the log files. There's so many different data sources, and one of the challenges that we've found is even the source definitions will actually change pretty frequently, right? If you're a smaller company, your product is iterating relatively fast. That means that the source definitions are going to change at the source and then create a whole bunch of hell downstream in whatever the data warehouse, the transformation. So talking with companies where they say, hey, the product team changes something, and for like the next 2 weeks our dashboards are broken as we try and figure out the impact of this change downstream. And what we've been working on, because again, we have this nice end-to-end understanding, is look, if you change your table DDL upstream here, or you change some transformation here, what is the impact for all of the downstream tables? And if we can provide a nice way to visualize that, create a report, all of a sudden there's this very clear or a much more clear process between something changes on the product end or on the ingestion end, and we know what's going to change downstream and how to work with that and how to deal with those problems.
Yeah, and I think again back to the shift lefting, I think this would actually be super useful for software developers too, because right now you have the notion of schema migrations, for example, right? Which there are some checks that happen in those, but I've definitely seen some like explode themselves and cause quite a bit of damage. You have to roll that back, but say that. Yeah, there's just a lot of impact. I think this across the board, this is quite interesting. Actually, you want to take a question here? I was been kind of sitting here for a bit. Garishima, I think is her name, asks, how is classifier different from adding extra column of information to a table? So suppose currency type can be an additional column. If the column is derived from the other table, that table name can also be added as another column. What are your thoughts on this?
This is actually great. It's actually a great point. I think for currencies, a lot of the time, you have the value and then you have the currency type. So absolutely, in that case, this actually wasn't even the best example. But there's a lot of cases where you don't typically do that. So what we've seen, and what probably everybody here has seen frequently, is that companies will have a particular key column and then a JSON structure as the next column. So just adding a third column that describes what maybe the JSON structure isn't enough, right? You need some understanding of almost sub-column level lineage within that JSON structure, right? If something is an object with an array inside of it, we actually just want to add a classifier to that particular object inside of the array. And for that, just adding another column is not enough. The same thing goes for privacy or data retention policies. It's hard to define data retention policies as an additional column that you add to a particular table, because retention for the whole table might just be dependent on what's happening in a single column.
Right.
And classifiers are a much neater way to sort of express higher level business logic than just adding an additional sort of definition column to the schema. That's a great question, though. That was a very, very good question.
Great question. More questions like this, please, from the audience.
Cool.
You look like you want to say something.
Yeah, well, I'll ask this question. So I really like this idea of moving left in data. This looks like a fantastic tool to accomplish a lot of that in terms of integrating teams working together. But what would be your thoughts for the organizational aspect? So if I'm working on the analytics or data warehousing side, what should I be doing to facilitate moving left?
Besides quitting your job.
Right. Besides quitting your job.
Yeah. So for a very long software, I think, has done a very good job of shifting left, right? If you look at the state of software engineering tooling, you've got integration tests, static tests, you've got CI/CD checks, you have IntelliSense that is rich and contextual, right? And partially because of the structure of SQL, partially because of, there's a source of truth question in databases that you don't have in code, right? And with databases, even like with dbt, for example, you want your source of truth to be in the code base. But the actual source of truth is your Snowflake instance or something, right? Like you can still have a Fivetran job that is completely independent of your dbt project that does some crazy stuff in the database and ruins the dbt project. And I think this has made it extremely difficult to shift left in data. So I don't know exactly what the best option is here. I think what we're trying to sort of position ourselves to do, and what is really great to see other companies doing as well, is add more guardrails in the CI/CD process. Because ideally in the CI/CD process, you haven't actually done the transformation, right? You haven't actually shipped a bug in production yet. So I think if we can even just move things from, hey, here's a transformation, we find out 3 months down the line that there's a problem here, to, hey, there's some integration tests in the CI/CD pipeline, and we get feedback there that this transformation is broken. I think that is already a really, really great start, and will solve a lot of especially the sort of the long-standing issues in data development.
Yeah, it seems like and again, I think that we only complete shift left, for example, when we actually shift left, and there's kind of end-to-end visibility between when data is created and when it's consumed by downstream stakeholders, right? And so that's, I think, as Matt points out, an organizational problem as much as it is, I think, just having the optics into the people providing you data. But again, back to Dave McComb's suggestion too, though, it's like if you're doing a third-party applications, you're a bit hamstrung. Not much you can do about that. But hey, control what you can control. I like that. And when you get the data in, you're querying it, so you sort of have a as I say, a data warehouse, right? Then you have a SQL that respects it.
Yeah, I think this is good. I mean, you had on one of the folks from Tabular recently. There's some cool stuff that even is happening on I think just on the storage side, right? Where it seems like there's a couple of places that are very great integration points for some of these checks, right? And the storage layer is really, really great if you're dealing with governance and access control, because then it doesn't matter what you're building on top, right? You can have an infinite number of weird data access points on top, but if the actual ACL policies are at the storage layer, fantastic, great. Then it doesn't matter what some other business units builds on top of that storage layer.
Right.
So I think what I'm sort of interested to see is if there's more of these sort of control plane technologies that enter the market, where there's one control plane, and then it doesn't matter what is built on top, because the business logic sort of sits at this control plane. And yeah, I think ultimately we're hoping that SDF can be one of those sort of control plane technologies, because it really does have this end-to-end visibility.
Back to currency. Jake Carter
Back
has
to currency.
Comment/question here. If you want to track the data points amount of USD, you'll want to know what the other data points went to the USD data points. You need to know that a Canadian dollar amount was used to generate the US dollar amount. I think this is where a classifier for Canadian dollar would be a good way to have context in the upstream data points. ?
Yes. So if I'm understanding this correctly, so if you have context upstream and then understanding of the transformation is even more valuable than just knowing the state, than the current state. So absolutely. So there's actually some really, really sort of great examples of this that we've run into. So we showed some hashing, right? SHA-256, MD5. There's a bunch of consistent hashing frameworks. It's very hard for a human to look at a hash and know what it is. That's the whole point of the thing. It's very nice to hash person identifiable information to make it no longer PII. And what we've seen a lot of companies do is essentially blast hashes in all sorts of different places to get rid of PII and help with deletion and retention and so on and so forth. But sometimes you actually want to use fingerprints to sort of establish uniqueness, right? Especially in ML models. So let's say you have, a phone number, which is PI, and then you hash that phone number, and then you have an address, and you hash that address. Those hashes look exactly the same, but
Whoa, you just like turned
what's
into
going on
a
here?
disco place. I don't know what happened there. That was
That was awesome. I don't know what happened there either. That was
that was pretty
great.
cool. Yeah, you
Yeah.
must have magical powers or something. That was
If I do something like this, I have no idea. So yeah, so what I was saying was, let's say you hash a phone number, you hash an address. Those hashes look the same. Sometimes maybe you want to see if you can join on those two hashes. You can't actually, right? But you as a user, you might have, other than looking at the column name, you have no idea what that hash actually is. So it's very easy to lose the semantic understanding of what that information actually represents, even if it is clearly a fingerprint for something else. So understanding transformations from end to end is, I think, much more valuable than just having sort of point understanding of what a particular column is.
well, cool. Any other questions from the audience here? Matt, you got questions? I think it's,
Maybe this is too far off in the weeds, but what are your thoughts on, so Facebook and Google, of course, started using hashes some years ago for their advertising platforms. And then very quickly, people figured out that you could just take a list of email addresses and hash it using Google's algorithm and then match with data that you, so what are your thoughts on mitigating that? Maybe that's too far off of the main topic.
No, that's a good question. So I think in general, the problem there was there's you want consistent. So consistent hashes, the idea is that like whatever you hash the same value multiple times over time span, you get the same value. And they're using consistent hashes with no salt. What you want is to add a little bit of a salt there that is unique to Google and only Google knows it. So that even if you take the same hashing algorithm and hash an email address, you still won't get the same information back. So I think that was an engineering oversight. rather than it was actually pretty major engineering oversight. So yeah,
we'll just use quantum computers. It's fine, don't worry about it. Actually, Jake Carter asks, is there a free version, trial, or community version of this?
And there is, so we're currently working with some customers in essentially closed beta. If you're interested in sort of learning more, feel free to send me an email or add me on LinkedIn, and I'm happy to give access, hear what your use case is, and see if this tool actually is a right fit.
Cool.
So, yeah, absolutely.
Good. Awesome. Well, it's been good having you on the
Great.
show. I actually have to close out in a second, so I got to go to the airport. So
head to the airport. But yeah, no, it was great talking. I really appreciate all the very, very interesting and in-depth questions.
Yeah. Hopefully, this was a great time for you. It looked like it was with the big party lights in the background. So I still have no idea how that
Monday
happened.
morning.
Is there a gesture you can do that would like?
I have absolutely no idea how we launched this.
It must be just StreamYard. It must be on drugs recently. It's like late.
It might be.
It has tracers.
It steals money out of the cash register, like all kinds of stuff.
Yeah, exactly. Mariah is asking, Joe, traveling. Yeah, I'm off to India in just a bit. So, and then Dubai. So there you go.
Yeah, it's a big trip.
Cool. Well, yeah. Anyway, yeah, have fun. We'll put links in the show notes, all that fun stuff. Matt, you got anything you want to talk about? Anything coming up? You're at Coalesce next week, by the way.
I'm at Coalesce next week, yeah. So I'll post some more about upcoming panels and such at Coalesce. But yeah, I'd love to catch up with people there if you're going to be in town.
That'd be sick. Yeah, I wish I was at Coalesce, but
you're in India instead.
Not there, no, man. DoCon. So if you're in Bangalore, come meet up with me. Should be fun. And then got GITEX next week in Dubai, so that's gonna be pretty dope. No idea what to expect there. I think it's supposed to be a big tech conference in Dubai. So,
cool.
So you get a guy like me showing up there.
Sweet. Yeah.
Not
should
business,
be-
not dressed up, not dressed to impress. I can tell you that. Anyway, good time. And then, oh yeah, big news. Well, not big news, but for next Monday's data chat, I don't know. We might have it, we might not. I think Matt will be hitting it if we
Yeah.
do, because I'm going to be on the other side of the planet at the time. So, not sure. What the
Yeah,
time
let's decide. We'll post something soon.
We'll post something soon. Exactly. Then actually after that, I'll just kind of rail off who's on the show next. Kevin Hu from Metaplanes on the 23rd.
Cool.
So that's gonna be dope.
It's been a while. He's been on a couple of times over the years, right? But yeah, it's been a bit.
Yeah, he's always fun to talk to. We always nerd snipe each other, as he always says. So anyway, well, cool, Lucas. Fun having you on the show, dude. Yeah, and maybe we'll have to get out and climb since I was at the climbing gym on Friday, and Lucas and I having a quick call. Then he's like, you know, mentioned the climbing gym, and I was like, my friend works there, and I was like, you mean your friend that's like standing 10 feet away from me?
Yeah, that was a real small world moment.
It's just a very small world thing for sure. Yeah.
No.
So yeah, come out to Salt Lake, man. Good
Yeah,
climbing
I'll
out here.
let you know
It's
next time I'm
gonna be
in
season.
Salt Lake.
Yeah, for sure. All right, take care,
Cool.
everybody. Talk soon.
Awesome.
Bye.
Thanks a lot, everybody. Bye.
Bye.